Nice to meet you. I'm Yong-Jun Shin, a PhD student of KAIST. I'll introduce our artifact paper, Platooning Legos. We proposed a physical experimental environment for an industrial vehicular technique, platooning. From now, I'll provide a brief overview of platooning Legos. First, I'll introduce what a platooning is. Platooning is a method for driving group of vehicles together. Every independent vehicle is an adaptive cyber-physical system. It drives automatically and makes decisions based on the environment monitoring. It must prevent collision with unknown vehicles or any obstacles. Without any collision, it should maximize its travel speed as much as possible. In addition, the platoon is a system of systems, not only a CPS. It has high-level goals that can be only achieved by collaboration of constituent systems. The constituent vehicles communicate with each other so that they drive in a row and minimize road occupancy for saving fuel consumption and releasing traffic jam. Platooning is an industrial example of CPSOS. In the modern systems, we could find more examples of CPSOS such as collaborative robots in a factory or smart defense systems. As a self-adaptive system researchers, when we design or implement adaptation methods of a CPSOS, at some point, we need to validate our methods. At that time, we can consider two experimental options. One is real-field experiment, and the other is simulation-based experiment. Both have their own limitations. Real experiment can validate the methods on the real environment, but it costs very large. In addition, to deploy the system, not only software implementation, but physical implementation is also required, and to do that, expert knowledge of various fields are mandatory. It also has safety risks. On the other hand, simulation-based experiment is cheap and safe. However, no matter how realistic the simulation is, it is not a perfect reality. Engineers are limited to express the real environmental uncertainties of the system. To tackle these difficulties, we proposed a solution to make a semi-realistic experimental environment using programmable Lego. Platooning Legos is a physical experimental environment for engineering platooning method. It has three main characteristics. First, it is an industrial vehicular model problem, representing adaptation problems in CPSOS. Second, it is a physical exemplar. Although Sim's community has accumulated various common experimental environments for our research, we still lack physical experimental environments. This allows to have experiment with physical sensors and actuators and their real data. Third, it is an open physical exemplar, so it is really easy to build the same environment in your own place, and it is cheap comparing to having real vehicle experiments. So it will allow researchers to have realistic platooning experiment. If you use our Platoon Legos, you'll follow these steps. First, you implement your real system following our building manuals. You can have your own CPSOS and its environment. Second, because the Lego building manuals is really easy, you can spend more time to build your adaptation mechanisms that will be embedded in each vehicle. It is written in Python. After that, you can simply run your adaptation mechanisms on the robot vehicle and have experiment with injecting uncertain situations. You can collect the experimental data and analyze it. This is how we mimic the real CPSOS using the programmable Lego. Engineers can implement the whole map adaptation process of a vehicle in a Lego vehicle. A vehicle monitors peer situation through Bluetooth connection, driver's manual command through buttons, distance to front obstacle through ultrasonic sensor, and its road through color sensor facing down. Based on the monitored information, the vehicle analyzes and plans its operation in the LEGO OS brick. Its name is EV3. Engineers implement the adaptive decision-making logic in the brick using a Python library. They can also save the vehicle's operation data as a CSV file. The actuation of a vehicle is controlling the motors. The vehicle control library gets two inputs for driving control. One is driving speed and the other is turning ratio. Therefore, the adaptation logic's input is a set of monitored values, and the output is a set of driving speed and turning ratio. It abstracts complicated behavior of real vehicle into a Lego vehicle. We provided the Lego building manual and simple software skeleton on our paper and repository. Not only the vehicles, we also need to abstract the driving environment. Using this design, we abstracted an infinite two-lane highway. There are inner lane whose left part is black and outer lane whose right part is black. We designed pieces of the whole road in A4 size papers. We also provided the blueprint of our repository. Users can just print the blueprint, cut it, and paste it on the floor. After engineers finish the whole physical and software implementation, they can run their LEGO platooning vehicles on the road environment. In this paper, we provided a sample implementation and its experiment result. Let's see the sample experimental video and check how our sample platoon adaptively achieved its goals during the operation. In summary, we proposed an open and reproducible physical experimental environment. Everyone who wants to validate their adaptive platooning methods on a realistic environment can use our platooning Legos. It will reduce burdens and costs of building a CPSOS, and it will allow engineers to focus on building their adaptation methods and validate them realistically and easily. If you have any questions or difficulties to use our platooning Legos in your place, feel free to contact us. Thank you for listening.